Right, so in mass volume calculations, we must remember that we can use the molar volume of 22.4 cubic decimeters only at STP. If the reaction is not at STP, you'll need to calculate the molar volume by using this equation. R stands for the universal gas constant and T stands for temperature. We will still do this. I won't make the same mistake again.
What mistake did you make?
I didn't do gas laws before I did quantitative, so I'll do the quantitative after gas laws.
But we're not going to use that today.
Now here comes it. What is the formula for potassium chlorate?
K is
K
ClO.
ClO3.
So chlorine.
Okay, that is thermally decomposed and it makes oxygen and potassium chloride. So this is a decomposition reaction. Okay, let's balance it. 2 of those, 3 of these,
And
2 of those. Okay. So 2 moles of potassium chlorate will give you 3 moles of oxygen. They give us 90 cubic decimeters of oxygen. We need to change that into moles by using V over Vm. That will be 90 divided by 22.4, which is
4,02. Yeah. Now we times that by 2 over 3.
yeah. So you have to divide by 3 and times by 2 or multiply by 2 over 3. The 2 over 3 I get from the mole ratio. And you get 2,68. Yes. Because the mole ratio is 2 moles of potassium chlorate will give me 3 moles of oxygen. So how can I change 3 to 2? How can I change 3 to 2? I can multiply by 2 over 3. If this is a 1, I multiply by 2. If it is a 2, I multiply by 1. If it is a 3, I must multiply by 2 over 3. Because I need to change this 3 to a 2. Are you with me mathematically?
No. Yes.
How can you say no?
It's simple mathematics.
It is. So this mass will be moles times molar mass. So it's 2.68 times, what's this molar mass? 39 plus 35.4 plus 48.
122,5.
Comma?
3.
Grams.
Yeah.
Right. This one is now tricky. Ammonium nitrate is used as an explosive in the mining industry, and they say 750 grams of ammonium nitrate is decomposed thermally, or they send a spark through it and it will ignite it, and it produces nitrogen and water vapor and oxygen. And we need to balance this reaction equation. 2 moles to 2 moles to 4 moles to 1. So 2 moles of ammonium nitrate will give us 1 mole of oxygen. Now they tell us what volume of oxygen would be formed at 550 degrees Celsius and 1 atmosphere, which is 101.3 kilopascals. We're not going to be deterred by that information. We are going to follow the steps. So first of all, I need to change this into moles.
That's 750 over 80. Which is 9,375 moles.
9,375 moles. Now the ratio between the ammonium nitrate and the oxygen is 2 to 1. So that gives me, I need to divide by 2. So it's 4,
What? Oh, yeah. 4,675.
mole. Okay, now here comes the part where you are not on my planet.
Oh, you're on the next year. Man's on planet the next year.
It's
PV
NRT.
equals nRT. Now, these are the conditions for using this equations. P must be in pascals. V must be in cubic meters. Or you'll find on your data sheet. N is the moles. The T must be in Kelvin.
What is this for?
Okay, so sorry, bear with me, you will get there. Yes,
Why are we using cubic meters?
because
Conditions of the equation.
it's the condition for using this equation because of the unit of this quantity. Find this quantity, please, on the data sheet. 8, that quantity is 8,31, and there's a unit to it. Joules per Kelvin
Per mole.
per mole. Joules per Kelvin per mole. Okay?
It's just got weird.
Because this is the reason why we can't work with gases in degrees when we do calculations. Because you can't divide by 0. And you do get gases at 0 degrees Celsius. Now we're not dividing here, but the whole equation and the setup for gases is to use the Kelvin as a temperature. And a Kelvin, 0 degrees Celsius,
273.
0 degrees Celsius is 273 Kelvin. So all you do with the 550 is you add 273 to it. So the pressure is 101.3 times 10 to the power 3 pascals. The volume is what we need to calculate. The moles we've got as 4.6875. The R is this 8.31. And the temperature is 550 plus the 273. What is the value of the volume that you get?
Keep Simon.
What's going on here? I was still on the previous question.
You have to change degrees Celsius to Kelvin.
You get 0,32 man.
What's 0 degrees Celsius?
Cubic meters.
Cubic
Meters.
meters. And if you want to convert that to cubic decimeters, you just multiply by 1,000. That's 320 cubic decimeters. The cedi.
Don't you have to
So
do it at the
in
end of
order to
22?
convert degrees, you just pass the.
273.
Just like
Why is it counting? Who's counting?
11th and grade 5. 1,000 times 1,000.
So we divide by 1,000.
What was that guy's name?
Multiply by 1,000.
Right?
Kilopascals. Yeah,
Meters
that guy tried to
to
beat me up.
cubic
How much
decimeter.
He tried.
Times 5,000.
I don't remember, but he tried to punch me in the
You
face.
times,
Oh, because there's 1,000 cubic decimeters in 1 meter.
yes.
That guy just moved on.
Yes,
There's 1,000
in
centimeters
1 cubic decimeter you have 1,000 cubic decimeters.
Pick a side. What does the 1
The
over
actual answer is 116.
What does that?
The 101,3 kilopascals is the pressure at which this gas is formed. Atmospheric pressure.
Calculates to 1
Okay, KPA is atmosphere.
Yes.